Hello and welcome to this session. I'm your instructor Rajesh Durbala and we are going to discuss statistical inferences, that is hypothesis testing for single populations. So moving ahead, basically if we talk about any kind of marketing research or any business research, the concept of hypothesis testing abounds. For example, let us say we keep talking about, for instance, the department store is being patronized by more than 10% of the households. Or maybe we say this brand is preferred by more than 50% of the population, or this brand captures 50% of the market share. Fine. Certain examples, like recently I came across an example which says, like Colgate is the most preferred toothpaste in the country and it enjoys a market share of around 55%. Okay, so all these examples are maybe all these examples are basic analysis which involves hypothesis testing. So in this session, this is what we are going to cover. What is hypothesis testing for single populations? So, what are the learning outcomes? Upon completion of this lecture, you will be able to understand what hypothesis testing procedure is using one-tailed and two-tailed tests and concepts of type 1 and type 2 errors in hypothesis testing. So, we'll learn what are the various steps involved and we'll get to know what are the errors that could be committed during hypothesis testing. And number two, we are going to learn how to frame null and alternate hypothesis in research. And finally, we will develop the skill how to test the hypothesis and identify the test statistics for inferential analysis. We will be doing certain practical problems to understand how this is carried forward, but that would be in the part two of this session. So today we'll be covering the conceptual elements, and in the coming lecture, we would be covering the problem solving and the practical elements of how hypothesis testing is carried. Fine. So basically, let us try to understand what is hypothesis and what the definition of hypothesis is. So hypothesis is an assumption of an unknown parameter. Okay, unknown population parameter. So I make an assumption about the population, and that is what a hypothesis is. Okay, I would say like 50% of the population prefers this. That is a hypothesis. Okay, because I'm making an assumption about an unknown parameter. Fine. Likewise, so hypothesis testing is a well-defined procedure which helps us to decide objectively whether to accept or reject the hypothesis based on the information available from the sample. Okay, I make an assumption about the population and then I follow a well-defined procedure using basic statistics derived from a sample, and I would decide whether to accept the hypothesis or reject the hypothesis for the entire population. And then in statistical analysis, we use the concept of probability to specify a probability level at which a researcher concludes that the observed difference between the sample statistic and the population parameter is not due to chance. Okay, that is what we say level of significance or confidence level, and that is a probabilistic level which is the accepted level of tolerance. Okay, and if the sample parameter falls within the acceptable region, we accept the hypothesis. If the sample parameter falls out of the acceptance region, the hypothesis is rejected. Okay, so these are the various steps involved. You can pause the video and make a note because I'm going to describe each and every step in great detail. So let's see what is the step. You can pause it and take down the steps. Okay, I'm not going to read down the steps right now because I'm going to discuss all the steps in complete detail. So step one, that is set null and alternate hypothesis. Okay, so the first step is I'm going to formulate the null hypothesis and alternate hypothesis. So how does that work? Now, the null hypothesis, generally it is referred as H naught or H sub 0. Okay, that is the symbolic representation of a null hypothesis. And this null hypothesis is tested for possible rejection. Okay, under the assumption that it is true. So first, if I say mu equals h naught. Mu is the population parameter. That is, if the mu or let us say the mean household income is $10,000 or a lakh of rupees. Okay, so that is a null hypothesis. So I would frame my null hypothesis here as mu equals $10,000 or 1 lakh rupees. That becomes my null hypothesis. Okay, and that is tested to reject. I just deliberately I want to prove that this is wrong. Okay, that is what the objective is. So null hypothesis is a parameter which is tested, okay, which is tested for possible rejection. Okay, and under the assumption we assume that it is true and it is tested to reject it. Okay, but if we find that the sample parameter falls within the acceptance region, so I can accept this hypothesis. So the first step what we do or carry forward in hypothesis testing is we formulate the null and alternate hypothesis. And null hypothesis is a statement, we can also call, yeah, this is very important. We also call this as the statement of the status quo, one of no difference or no effect. Okay, so if the null hypothesis is not rejected, no change will be made. So that is very, very important. If the null hypothesis is not rejected, so no changes will be made. Now, uh, again, if I talk about an alternate hypothesis which is represented by H sub 1, that is H1, and it's a logical opposite of the null hypothesis. Okay, so if I say mu equals $10,000, I would say mu is not equal to $10,000, or mu is greater than $10,000, or mu is less than $10,000. This is how H1 is formed. Okay, now you have to again let us say an alternate hypothesis is one. Okay, it is one in which some difference or effect is expected. Accepting the alternate hypothesis will lead to changes in opinions or actions. Thus, the alternate hypothesis is the logical opposite of null hypothesis. If we go further in the argument, I would say that the null hypothesis is always, okay, it is always, the null hypothesis is always the hypothesis that is tested. Okay, we are not testing the alternate hypothesis, we are testing the null hypothesis. The null hypothesis refers to a specified value of the population parameter. It could be like mu, or it could be sigma, or it could be pi, or anything. Okay, not a sample statistic. So null hypothesis is always a population parameter. Very important point to note down. You can note it down that a null hypothesis refers to a specified value of a population parameter, not a sample statistic. Okay. So a null hypothesis may be rejected. It can be rejected, but it can never be accepted based on a single test. So you can reject it, but you cannot accept it based on a single test. Okay, a statistical test can have one or two outcomes that you have to take care of it. If there is one, uh, let us say one of the outcome is that the null hypothesis is rejected and the alternate hypothesis is accepted. The other outcome could be that null hypothesis is not rejected based on the evidence. However, this should be kept in mind. It would be incorrect, or it would be wrong to conclude that because a null hypothesis is not rejected, it can be accepted as valid. Okay. So if you cannot reject it, it doesn't mean that you can accept it. These are very critical elements. You have to keep it in mind. So in classical techniques or in classical hypothesis testing, there is no way to determine whether the null hypothesis is true. Okay, so there is no established way in classical techniques to determine whether a null hypothesis is true. But in marketing research, the null hypothesis is formulated in such a way that its rejection leads to acceptance of the desired conclusion. Okay, so in marketing research, we just, in business research or marketing research, we just tweak the framing of null hypothesis in such a way that if null hypothesis is formulated in such a way that if it is rejected, let us say, it leads to the accepting of desired conclusion. The alternate hypothesis represents the conclusion for which evidence is sought. For example, a major department store, let us say, is considering to introduce or introduction of an internet shopping service. Now, the service will be introduced if more than 40% of the users shop via internet. Now, the appropriate way to formulate the hypothesis would be, let us say, H naught would be, let us say, pi less than equal to 40, that is minimum less than equal to 40%. Okay, and H1 would be pi greater than 40%. Now, if null hypothesis is rejected, then the alternate hypothesis will be accepted and the new internet shopping service will be introduced. On the other hand, if H naught is rejected, then the new service should not be introduced unless additional evidence is obtained. So this test of null hypothesis is called like one-tailed test. Okay, I'll discuss those what are one-tailed and all in later stages, but let us try to understand. Okay, so whenever in hypothesis testing, if you have a alternate hypothesis like this, greater than or less than, okay, then it is called a one-tailed test. And if the alternate hypothesis has uh, not equal to, okay, the not equal sign, then it is a two-tailed test. So greater than equal to one-tailed test and not equal to is a two-tailed test. We'll discuss this in detail. Now, next is we need to determine the appropriate statistical test. Now, what does that mean? Now, to test the null hypothesis, okay, in order to test your null hypothesis, it is necessary to select an appropriate statistical technique. Now, without a proper or appropriate statistical technique, the acceptance or rejection of hypothesis could be flawed. Now, the researcher should take into consideration how the test statistic is computed and the sampling distribution that the sample statistic, that is the mean, follows. The test statistic measures how close the samples have come to the null hypothesis. Now, when I'm selecting a test statistic, I'm just simply trying to check how close the mean or any other sample parameter, how close it has come to my null hypothesis. Now, the test statistic often follows a well-known distribution, such as maybe, again, this is a very, very important thing. When you are selecting or when you are determining an appropriate test, you should ensure that your test statistic often follows any of the established distributions, that is a normal distribution, t-distribution, or chi-square distribution. Now, guidelines for selecting an appropriate test or statistical technique will be discussed. I will be discussing it, but you have to understand that any test statistic that you are selecting should follow any of these well-known distribution parameters, such as normal distribution, t-distribution, or chi-square distribution. Now, currently, let us say the z statistic, which follows the standard normal distribution, would be would be appropriate, or let us say how would we compute that? That is more important. Like you may know, if we compute z is p minus pi divided by sigma. Okay, we'll discuss that, but it's important that you need to decide on your statistical test, which statistical test. And when you are deciding the statistical test, it is pertinent to see it is following an established distribution. Okay, and what we are trying to do in with a statistical test, what are we trying to achieve? We are trying to just check whether the sample parameter is coming close to your null hypothesis or not. Fine. Third step. Now here we are going to set the level of significance. Okay. Now what we are trying to do is we are trying to denote a level of significance which is denoted by alpha. Okay. And it is the probability level which is associated or attached to your null hypothesis. That is to say, which may be rejected or accepted based on this level of significance. Now this level of significance is also known as the size of rejection region. And if we keep this if let us say level of significance is high, okay, level of significance is high, then the acceptance region will be small, rejection region would be large, right? So now more importantly, like whenever we are drawing inference about a population, there is a risk that an incorrect conclusion will be reached. Now there is always a tendency to commit two types of errors, that is type 1 error or type 2 error. I will discuss that on a later stage, but your type 1 error, you have to remember your type 1 error and type 2 error are associated with your level of significance. Okay, now next is I'm trying to set my decision rule. Now, what is the decision rule I'm trying to establish? Decision rule is, now if you can see this uh, in your distribution, this is a bell-shaped curve. I'm just defining my critical region. Now, let us say I'm taking a two-tailed test. Okay, two-tailed test is I'm testing on both the regions. I have rejection region on both the sides, and this is my cutoff Z score. Okay, whatever alpha I have, that is alpha is level of significance. Let us say if I'm working on alpha of uh, zero point 0.5. Okay, so that is 2.5 over here and 2.5 over here. Okay, sorry, not 2.5, it's 0.25. 0.25 this side and 0.25 this side. Okay, and whatever is left in middle, see, most often if we go back, level of significance, usually we researchers, we like to take our level of significance as 1%, 5%, or 10%. Okay, try to understand this. Now when we use this, for instance, this picture or this diagram, I have used level of significance of, let us say, for instance, okay, this is just an example. Let us say if I'm taking 5%, that is 0.05. If it is a two-tailed test, that would be split equally. Okay, you can see alpha by 2, alpha by 2, that is 0.05 divided by 2 and 0.05 divided by 2. So this side, this is minus z, and this side it's positive z. This becomes minus 0.25 and this becomes plus 0.25. Okay, so this is my null hypothesis which is getting tested, and the acceptance region is 1 minus alpha, that is 1 minus 5% or 1 minus 0.05. That becomes 0.95. So 0.95 probability is for the region of acceptance, and 0.25 on the right side of rejection, and 0.25 for the left side rejection. Okay, so if I'm testing a hypothesis and if my calculated Z value falls within the rejection region, either on the right side or on the left side, my null hypothesis gets rejected. And if it is within the acceptance region, it becomes accepted. Okay, this is how the two-tailed test works, and this is how I set my decision rule. Okay, decision rule is where am I putting my critical values. These are my cutoff boundaries. Fine. And then collect the sample data. And now what I'm trying to do is sample size. I'm determining the sample size. So sample size is determined after taking into account the desired alpha and beta errors, that is type 1, type 2 errors and all, and other qualitative constraints. Now just see, in the stage of sampling, data is collected and the appropriate sample statistics are computed as we have discussed, whether it is a t-test, z-test, whatever, we compute the necessary statistics. The first four steps should be completed before the data collection. Whatever steps we have discussed earlier, like set the null hypothesis, alternate hypothesis, decision rule, all these things should be completed till now. It is not advisable to collect the data first and decide on stages of hypothesis testing. Okay. Now your analysis of the data. This is simple. In this step, now the researcher has simply to compute the test statistic, and this involves selection of an appropriate probability distribution for a particular test. As I told you earlier also, some of the commonly used testing procedures are Z-test, T-test, F-test, and chi-square test. Okay. And now the seventh step is we arrive at a statistical conclusion, and we make a business implication. Now in this step, we or the researchers draw a statistical conclusion. A statistical conclusion is a decision to accept a or reject a null hypothesis. We have discussed this earlier also, like if the null hypothesis is close to the parameter or within the acceptance region, we accept the null hypothesis. If it falls within the rejection region, we discard or we reject the null hypothesis. Now, statisticians present the information obtained using hypothesis testing procedure to the decision makers, and the decision makers, on the basis of this information, they try to make any decision, or ultimately a decision maker decides that a statistically significant result is substantial result and needs to be implemented for meeting the organizational goals. So whether to uh, carry forward or whether to act upon the decision or not, it's the it's the prerogative of the decision makers of the business. So the statistician or the researcher, he works on the hypothesis, tests it, and gives his feedback to the decision makers. Now let us try to understand what are two-tailed tests. As I told you earlier also, uh, one tail test or two tail test is not affected by the hypothesis, null hypothesis. Null hypothesis remains the same. If it is a two tail test, we have this not equal to in the alternate hypothesis. That is, let us see, two tail test contains the rejection region on both sides of the test, both sides of the tails. Okay. Now, for instance, we have seen this curve earlier. Now, this is a two tail test, okay, because it has rejection region on both the sides. Fine. That is what we mean by this. Now, this means a researcher will reject the null hypothesis if the computed sample statistic is significantly higher than or lower than the hypothesized population parameter. If it is significantly higher, then it will fall into the right side rejection region. If it's significantly lower, it falls on the left side rejection region. As simple as that. So this is how it works. Now, if I'm taking if I'm taking alpha as 0.05, you can see 0.025 on the right side, 0.025 on the left side. So this forms the rejection region on the right side. If this forms, and this forms the rejection region on the left side. And the calculated Z value, or not calculated, in fact, the tabulated Z value, the Z value at this point, okay, for this probability is plus 1.96, and the calculated tabulated from, we get this value from the statistical tables of Z value. Okay, you can find the table in any standard statistics book or any RM book. So if I just check the Z value at a probability of 0.025, I get minus 1.96. So these are the values from the table. Okay, you get these values from the table. So when I get now this entire region is my rejection acceptance region, and this is my rejection region. So when I compute the test statistic of any research problem and I get a value which falls within this range of minus 1.96 and plus 1.96, the null hypothesis gets accepted. And if it is significantly lower than 1.96 or significantly higher than 1.96, your null hypothesis gets rejected. Now let's see the one tail test. Okay. Now you can see there is no effect on the null hypothesis. Only what's changing is the alternate hypothesis. Alternate hypothesis, if you have less than or greater than signs, this becomes one tail test. Now if it is less than, so it goes on the left side, left tail test. Okay. And if it is greater than, it's a right tail test. So it's quite simple. Now one tail test contains the rejection region on one tail of the sampling distribution of a test statistic. In case of left tail test, the researcher rejects the null hypothesis if the computed statistic is significantly lower than the hypothesized population parameter. And then in the right tail test, the researcher rejects the null hypothesis if the computed sample statistic is significantly higher than the hypothesized population parameter. If I see the values or in the graph, or if I see the curve, this is a left tail test. Okay, you can see a left tail test. Left tail test. Now the alpha, if it is a two tail test, I was distributing the alpha on both the tails. But if it's a one tail test, the entire alpha comes into that particular tail. Now, in this left tail test, this is the rejection region. The remaining 95% is this. Okay, this entire thing is my acceptance region. And for this 0.05, my tabulated Z value is minus 1.645. This value can be found in your Z value table. Now, when you solve your, or when you calculate your test statistic, and if it is greater than minus 1.645, it falls into the acceptance region. And if it is less than this, significantly less than minus 1.645, the null hypothesis gets rejected. And this is a right tail test. The logic is exactly the same. Now, if the test statistic is greater than, okay, when you calculate your test statistic for your sample parameter, and if the value produced is much greater than plus 1.645, you reject the null hypothesis. Anything less than this value, that is 1.645, you accept the null hypothesis. Fine. Now, let's come to type 1 and type 2 errors. This is very, very important. Now, you have to remember type 1 and type 2 errors. Okay. Now, if you are rejecting a true null hypothesis, your null hypothesis was true, but you rejected that, it becomes a type 1 error. Accepting a false null hypothesis is type 2 error. Okay, now you can see from this table, and if you are accepting a true null hypothesis, obviously it's a correct decision, and if you are rejecting a false null hypothesis, obviously again it's a correct decision. Now you can see this is how you work. Okay, now this is the confidence level. Confidence level can be calculated by 1 minus alpha. Alpha is your level of significance. Okay, that is 0.5, 0.05, 0.10 or 0.01. Okay, so you work at 90% confidence level, 95% confidence level, or 99% confidence level. That is calculated on the basis of 1 minus alpha. Okay, now alpha here you can see 10%, 5%, 1%. Okay, now one tail region, the limits are plus and minus 1.28. Okay, and plus if it is 95% plus or minus 1.645, 99% it is plus or minus 2.33, and if it is a two-tailed region, this is what gets split, plus 1.65 and minus 1.645 plus 1.96 and this. Okay, fine, these are the values. Most often in your exams or anything, these values are provided in the form of table, or else if you're doing it for your research, nothing to worry. Any of the standard textbooks, like let us say I follow Naresh Malhotra, I follow Bajpai, Naval Bajpai. So you have another good books. Now you can follow any of the good books and you will easily find the table either at the beginning of the book or at the end of the book. You can easily use those tables for your any kind of research or calculations. Fine. Now the errors that could be committed. Now if you are accepting an H naught and H naught true, okay, correct decision with confidence level 1 minus alpha, and H naught false, okay, and if you are accepting, then you are committing a type 2 error. Okay, reject H naught, and if H naught is true, you are committing a type 1 error, and reject H naught when H naught is false, it's a correct decision. Okay, so if you remember this matrix, it gives you the power of test. Okay, the power of the test can be easily like 1 minus alpha, and type 1 error, if it's correct, that is type 1 error, it is alpha. Okay, and if it is type 2 error, it is beta, and the power of test would be 1 minus beta. Okay, so 1 minus alpha is the power of test and 1 minus beta is the power of test. 1 minus alpha in case of uh, for 1 minus alpha in case of type 1 error, 1 minus beta in case of type 2 error. Okay, so in the coming session we are going to discuss some real problems and we will learn how to apply statistical hypothesis testing for deriving statistical inferences. Thank you for watching. Keep visiting this channel. Do subscribe, like, share, comment, share it with your friends, spread the good word about this channel. Thank you.
Audio Jungle. Audio Jungle.